Implementation of DFS algorithm in C language. Now let's begin writing code to implement DFS algorithm. First we will include headers. Hash include stdio.h, hash include stdlib.h. stdio.h required for input-output functions like printf. stdlib.h required for dynamic memory allocation, that is malloc. Now define the constants. Hash define max 100. This sets the maximum number of the vertices or size limits. Not used directly in this program but can be useful for static arrays or limits. Now define node structure for adjacency list. This represents each neighbor of the vertex. Each node stores in vertex the neighbor's index, in next pointer to the next neighbor, that is linked list format. Next, let us define the graph structure. Here num vertex is the total number of nodes in the graph, and adjacency list is the array of linked list. Each list contains neighbors of a vertex, and visited indicates the Boolean array to keep track of visited nodes. Now create a new node. This allocates memory for a new node, sets the vertex value, initializes the next pointer to the null. Next we will create a graph. So this allocates memory for a graph structure, and this sets the number of the vertices, and this creates an array of linked list for adjacency, allocates a visited array to keep track of visited nodes. This for loop initializes all adjacency lists to null and sets all nodes as unvisited, that is 0. Now let's add an edge. This function to add an edge between source and destination, and this adds the destination to the adjacency list of source, and this adds source to the adjacency list of the destination since the graph is undirected. So let's write the main function. Main DFS function starts from the given vertex, and this marks the current node as a visited, prints as its part of the traversal. Now let's write down the loop here. Loops through all the neighbors of the current node. If a neighbor is not visited, it recursively calls the DFS for that node. This is the main function. This creates a graph with 5 vertices 0 to 4. These lines adds the edges to build the following graph. Here you can see this graph and print it. Prints the DFS traversal starting from the 0 and return 0 ends the program.